Hi, math lovers. I wanted to make a super quick video just to go over this worksheet with you. You found this worksheet, the solutions, it's in our lesson plan for the day. I have all my work written out. You can certainly spend the time going over it. I just want to do a quick once over on all the problems, just so you know what you're doing. If you look at the first one, this first one, I would definitely have a star next to it if I were giving to you. I made up the problem, I loved it, and then I looked at it and I realized how much work it was involved. So definitely I added the two, here you can see I added the two equations together. And once I did that, I then had a beautiful factored problem right there, a beautiful factoring problem. And I have two answers for y. Once I then figure out what y is, I have to go back and plug it in to figure out what the x values are. And since I have two values for y, I have to plug it in 2 times. So if all the way down here you scroll, I see I had to go all the way down to give myself some extra room. First, I plugged it in when y is 5, and the second one I plugged it in when y is -1. Now, I don't think this problem is too difficult for any of you to do. I just think it would take way more time than I would give you on a quiz. So great problem. Make sure you can follow the logic, but again, a little more involved than I would ask you on just a 20-point quiz, okay? Going back to number 2, this one, number 2, is much better for us for a quiz question. I use substitution here. You can see that I went ahead and I figured out what y was equal to, and then I plugged it into the other equation here for y. Notice how I foiled it out. Some kids are going to forget that. Foiled it out. I went through and solved it, and I got all the way down here with my factoring. I realized that x is 2. Once I get that value of 2, I get to choose which equation to plug it back into. I think it's easiest to go ahead and plug it into that equation I solved for y, and I'm good to go. Okay. Questions 3 and questions 4, both of these are equations, systems of equations that you're going to plug into your TI-84. All right, love that TI-84. I have all the directions typed up for you and shared in case you missed it. That's in the lesson plan. You can look for those. But notice here, friends, notice how I had to first line up these equations. So my variables, all the x variables lined up, the y's lined up, and the z's lined up. All right, notice that. So before I could go ahead and use this last equation here, I had to change it so it was x, then y, then z, just like you guys would do. I'm sure you're smart enough to figure that out. Okay, scrolling down to the second page. Okay, so look at question number 5. We're going to figure out the determinant of each matrix here. Get me out of the way. So here in number 5, remember you cross multiply down, and then you're going to subtract the other multiplication. So that's how I end up with 20. You could take the time here and plug this all into a calculator to figure out what the determinant is, but this is so much faster. Same thing with question 6, you cross multiply, and remember you're always going to subtract right there in between. Remember the determinants here in both cases are non-zero, so there are inverses. Okay, both of them do have inverses. The next one, question 7 and 8, I would definitely put those two in my calculator. That would take a lot of time. We could use a Basking-Leibman method, which I just adore, but definitely go for the TI-84 there. And then the last two are Cramer's rule. We loved Cramer's rule. Cramer's rule had so much going on. Remember, we're using the determinant of each of these. And what I'm going to go ahead and do, and notice here, right here, I'm going to replace the x's and the y values in my numerator. I don't know if you can see that really well. With this 15, maybe I'll color it a little bit more. This 15, -15, 5, all right? So that -15, 5 gets replaced. Let me see if I can change colors here. Yeah, there we go, okay? So this value of -15, 5 gets replaced here in this column of the x's, here in this column with the y's, this column with the x's, and this columns with the y's. So that's our first step in all these problem solvings, is we're going to replace the x column and the y column in the variable we're solving for. Notice that my denominator is just straight up coefficients from the system of equations that's lined up. So we've got the x's, then I've got my y's, then I have my equal sign. I go ahead again and I do my cross multiplication here. Oh gosh, I've crossed so much out here. I'm going to cross multiply. Maybe I need another color. Let's use green. Okay. So I'm going to go ahead and I'm going to cross multiply in one direction. So I get negative 75. I cross multiply in the other direction. I get 30. Remember, we're gonna subtract right there in the middle. I do the same thing for the denominator. Negative 5 times 5 is negative 25. I cross multiply the other way. I get negative 18. Notice I'm going to do it a minus 18, negative 18. That turns into a positive, and that's how I come up with the 7 in the denominator. Okay. You can go through just a quick run through of exactly how to do the worksheet. I think you're going to be great. Remember, we have a quiz on this. You're going to have your TI-84, so you can check your work. If you wanted to, you could use another method to solve these two Kramer's rule questions, but I'm looking for you to solve using Kramer's rule. If you don't use Kramer's rule, I will not give you full credit for the question, and I won't give you credit for the question. Your job is to show me you know how to use all the tools in your toolbox.